Hello, everybody. My name is Farnaz. I am a data scientist by profession, a board member of Pink Programming, helping other women into tech and programming, and I am a co-founder of an early stage startup in Stockholm called Queen's Eye, and it is an ed tech or education technology startup. But today I would like to talk about game theory, or the science of decision making, and the applications we had within my team to use this theory for attribution and marketing attribution, which we will get into. So when you're hanging out with your friends or you have social interaction, or when you're observing politicians making decisions, most probably you don't think too hard about the science or the math behind the decision making. But there is a whole field of mathematics and science behind social interactions, decision making, and it calls game theory. Game theory is a branch of applied mathematics that provides tools for analyzing interactions between different players when their decisions are interdependent. So when one player's payoff is affected by another player's, or the combination of other players' decision. So game theory could be applied actually in many different fields: politics, military tactics, psychology, economy, just name it. And of course in business these days, and it has a strong application. Game theory was pioneered in 1950s by mathematicians John Nash. So if you watch this beautiful movie called A Beautiful Mind, it is very nicely shown the life of John Nash and how he came with the theory, etc. It's a very beautiful movie. I recommend that. Game theory has two main branches: cooperative games and non-cooperative games, or competitive games. The most famous probably example of competitive or non-cooperative games is the Prisoner Dilemma. I encourage you to read about it, but today I will talk about cooperative games and the applications it has, and getting back to the attribution models. But very briefly, cooperative games, I would say, is all about fairness, being fair, and competitive games are about being smart. So in the cooperative games, if we get into that, it's anything from splitting a meal between friends, or in fact a coalition of nations making a common decision about, say, climate change. It's applied to cooperative games. And game theory aims to understand situations where rational decision makers interact or possibly form coalition. A coalition is what we call a group of players in a cooperative game when they work together for a common goal, and each player contribute to a coalition, and how much they are actually contributing and how much they can gain from it, and how this could be fair. So imagine, if I want to explain really in a simple way, imagine you have three players. So each of these players individually has a weight or has a value, and a combination, or all the possible combination of these three players, has also different type of value or outcome. So if you identify each of these values and identify the value of each combination, and eventually if you calculate the average of this weighted contribution or marginal contribution of each player, you actually have calculated the concept of Shapley value, which is this average of marginal contribution of each player. So if I just go back to last slide, player A has a value of 7, but with the calculation of Shapley value, which is basically the average of all the combinations that A is part of it, A, or player A, would have a value of 7.7. So this Shapley value could be also calculated by this formula, and this is how we put this formula into code, and Shap library in Python can help us put our data set into it and just calculate the kind of like Shapley value of our attribution in the case that we had. But what is attribution that I keep talking about? I took the liberty of using Skyscanner's papers and articles because it's very fitting and is nice and easy to explain, and it's public out there. So attribution is when, for example, in this case, a director has won an award, and you want to see, well, is all the credit goes to just the director, or the agent and mom and dad and etc. also had a kind of like, a contribution to this achievement, and how is this distribution of credits between these players or different parties that they had contributed to this, right? In that sense, in a industry and in the companies, it is similar to the product departments. For example, in Netflix, sometimes they want to understand the continuation of it, the retention and new subscriptions. Are these attributed to, say, like a hit like Black Mirror or the Netflix originals, or to a like classic old series like Friends? Maybe the reason I subscribe. But the same goes to Spotify or Amazon. If they want to understand how would they attribute the credit for retention or new subscription, etc. This also can be applied into marketing, the attribution of credits to different marketing channels, which was our problem with my team. So the problem is how to assign the credit of a purchase or a conversion to the correct marketing channel. And of course, we assume that we do have all the data prior to the purchase, which is not the case. But eventually it's like, how would you give credit to different channels? Again, I took this from Skyscanner, and let me explain this very simply. Say that you are on Google search and doing different things, and all of a sudden an ad comes up, 20 best cities in Europe for this summer, and you just click on it, land on a blog post within a Skyscanner and read, and name Budapest is there. And it just is appealing, but you're not convinced, you don't want to go there. A couple of days later, you see another ad that it says like, why Budapest is the best choice for this summer. You click on it, you read about it. A couple of days later, you have a dinner with your friends. You talk about going somewhere this summer, and you start Googling different words and summer, vacation, Europe, cities. And it just comes like, the best deal for this summer, Budapest, Skyscanner. You click on it, you see the best deal, and with your friends, you're like, that is convincing. But then you don't talk about it anymore because you're drinking and having fun. A few days later, all of you call each other and just like, let's make this happen. Let's go to Budapest. Then you sit, and because you already have all the knowledge and I've heard about the Skyscanner so many times, you directly type skyscanner.net and go there and buy your ticket. So now what happens is that in industry, the attribution is or the credit is attributed to the last touch point when you bought your ticket, right? But that's not fair, because it was a collaboration of different players before you were convinced to directly type and go to the website and convert and buy your ticket. So that's why we talk about data-driven or algorithm-based models. And guess what? What would be the best kind of theory that could be fitting here for this algorithm-based attribution, or this little more this smarter way of doing it? It's game theory, and Shapley value would be a very good solution. One might also ask, why going through all this trouble? Well, if you could, which is a very, very difficult problem to solve, but if you could attribute correctly especially like in the marketing departments, you can optimize the spending on each channels and on the best channel, which is something that, of course, we tried to gain a better understanding, but it's very, very difficult. Return on investment, so you can increase that. You can understand the customer journey. I guess that is priceless. And a strategic investment. That was at least objectives that we thought it's worth the time for the team. So we came up with the first architecture of the data set that we had. So to build the first data set to be fitted to the model that we were building. And again, like the biggest challenge for us was the data set and how to make it clean and how to make it representative, how to make it like, remove the duplicates. And also the missing data is enormous. So for us, we started understanding the journey of the customers, or how much do we know really. At the end, we realized like around 40% we don't really know accurately anything prior to their last touch. Eventually, that first data set, we did fit it to the model with a SHAP library in Python, and also compared our model with last touch or linear base. So we had last touch, linear, and then the Shapley, and compared them to see like how they differ, how much we can understand from each of them, and how much improvements did we make, in fact, with this Shapley value. And that's not a secret. It's like, I guess like everyone is dealing with the challenges of good data. We had to go through the process of building even better data sets with more assumptions and aggregating different data sets and bringing a better data into the model. And as I always say, and I always hear from other people, it's not about the theory or statistics or the machine learning, it's about the data. And that is the biggest challenge also. And it was the biggest challenge within this project we tried to solve. With that, I say thank you, and I finish my presentation. Thank you.